Hiya.
Hello.
What's going on?
It's going good. How about
Sunny day.
yourself?
I'm good. Sunny day over there in Southampton, it looks like.
Oh, I wish. It's no longer sunny over here.
It's not. Oh, I see it. I see the bystander over there not moving. So, okay, it's a picture.
Indeed.
Gotcha.
Yes.
Okay.
Oh, but your background's very nice. At the
It is.
beach?
Yeah, it's the beach. I haven't been to this beach specifically, but I got sent pictures from a friend. This is in Cyprus. I've never
Oh,
been to
wow.
Cyprus. Yeah, I know. Beautiful, huh? Really,
Nice.
really nice. I'm looking back like I'm gonna look at it. What a dope, man. Oh my God. Anyway, let's see if we can do a little bit better talking about logistic regression as opposed to commenting how beautiful. I look back and there's a whiteboard back here. All right. Okay, so in the first part, I think we gave the equation specifically.
Mm-hmm.
And then I don't know if we actually went through and actually found out a way to talk about probability, the
We didn't get
probability.
through that, no.
Yeah, okay, because we were able, and let me kind of put this up on our whiteboard here. Let me
Mm-hmm.
get a nice one up here. Okay, all right, let's see if this, sometimes these don't work as nicely as we want them to, but let's see if we can get through it today. All right.
Sure.
So I believe it was the natural log, okay, of the probability of something happening,
Mm-hmm.
right? So we're saying x equals 1, right? So x is either 0 or 1, let's say. So let's say p equals where x equals 1, so a positive result, right?
Okay.
Over 1 minus that same probability, correct?
Sure.
I think we had that. And we wanted to be able to solve for P. Well, we may have gone over this now. This seems a little bit more familiar, but let's quickly over it.
Sure.
So if this is going to equal beta naught plus uh, beta 1 x1, right?
Mm-hmm.
This expression is what gives us a linear expression. And we're trying to solve for P. Yeah, we're trying to solve for P. We're going to raise each one of these. Sorry, take E and raise it to both of these things, right?
Uh-huh.
Okay, and then E raised to the natural log of something is just that something. And it is starting to seem more familiar here.
Yeah.
1 minus that P of X equaling, I remember, yeah, you corrected me on that one. I remember now. That's right, because I called it X equals 0 and 1 and mixed it up. That's right. So that equals now E, correct?
Mm-hmm.
I will just call it to the beta naught. We won't split it up just yet.
That's fine.
Beta 1 x1, correct?
Nice.
Okay. So at this point, yeah, then we multiply both sides by 1 minus p of x collectively, right?
Mm-hmm.
So that bit we can kind of cancel out a few steps here at once. So we have p of x equaling e to the beta naught plus beta 1 x minus p of x times that e raised to this beta naught plus beta 1x, correct?
Mm-hmm.
All right. Then we bring this guy over to the other side. So it becomes p. And I'm going to do a little bit of handiwork here because when I bring
Mm-hmm.
it over here, I have p of x minus this bit,
Mm-hmm.
just p of x times something. So that means I'll be able to factor out a 1 minus that, sorry, plus.
I was gonna
Aha.
correct you again.
Well, all right. You made me nervous. No,
Oh, I'm sorry. Sorry, continue.
that's okay. We're good under pressure. I can work good under pressure. I hope I do at least. E to the beta naught plus beta 1 x1. Right. Okay. So that whole bit is equal to what was left on the right hand side, which is just e raised to the linear expression.
Mm-hmm.
of 1, x1. Right. So basically, the end result in this case, let me see if I can tack on. Can I make this smaller? I wonder.
Ooh.
Let me see if I can make this a little smaller. Zoom.
Oh,
In a
do I
minute.
do this?
There we go. No,
There.
I think we're good. Yeah.
Excellent.
Nice. And I think, let me see if I can move all of this stuff up too, possibly. Let's try it, man. Boop. How's that? You see
Excellent.
it?
Mm-hmm.
Beautiful. Right. We're pros. So P of X, right, equals E to the beta naught plus beta 1 x1 over 1 plus that whole bit, right?
Indeed.
Beta naught. It looks like a theta. Beta naught plus beta 1 x. I don't know why I'm using x1. I'm thinking that's multiple logistic regression, but
Yeah.
we just got 1x here. All right, cool. Right. So when we see this, so when we said when a beta 1, which is the coefficient on x, and our x value, our continuous variable, that's
Mm-hmm.
going to let us know what's going to happen to the probabilities of scoring a 0 or 1 on this
Sure.
logistic regression. If it's positive, right, that means that we're getting E raised to bigger and bigger and bigger, more positive values, basically. Okay?
Mm-hmm.
So that means that the top will grow, the bottom will grow, right? But when E raised to this whole linear bit, when X is really, really, really big, is a really big number, and I got that over 1 plus a really big number, that should be close to 1.
Yeah.
So I imagine we would see a curve where we have our whatever our continuous variable is going to be along here. So I think we may have mentioned blood pressure.
Mm-hmm.
Blood pressure. And as we move to higher blood pressures, we have a higher chance of getting heart disease. So I think
Yes.
that was the example that we gave. Okay. So this would be getting close to 1 if this guy were positive, correct?
Sure.
And then if beta 1 was negative, then I'd get the reverse situation. This being 0, this being 1, and then that bit, I
Exactly.
believe. Okay.
Yes.
All right. So I've got some data that
Ooh.
yes, that I, that I lifted from, and I have the code that I'm using. I'll mention, I think I put in references specifically
Oh,
that,
fantastic.
yeah. So, so we're not taking, I didn't come up with it myself. I think it was from, um, well, anyway, I think I put in yeah, I think it's in the code. I think I've done that already. So
Sure.
let me share with you now because I've got our studio. Oh man, hold on. I'm not going to share just yet because I'm going to basically give away the 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 finale. Oh my God.
Oh no.
So let's not. Let's make sure that it gives the full impact here. Okay. All right. I know it seems kind of silly, but it's all right. Here we go. Share. There we are. Okay. Share this bit. Right. Okay.
Okay.
See it?
Yep.
All right. Okay. So, well, it was I was going to say stole. I borrowed it from UCLA here. Okay. So
Mm-hmm.
this was the link that was given for a data set that happened to be a perfect situation for a logistic model.
Sure.
So I was trying to generate different data, but I'm like, I kind of looked and found this specifically. So
Nice.
we want to give credit to UCLA. All right. All right. So we're going to use ggplot in this because we're going to graph some nice graphs here. All right.
Mm-hmm.
So let's try. All right, so I'm reading in some data here. Should I make this bigger? Let me see if I can.
You can do. It's all right on my screen, but if you want to make it bigger, please do so.
Is it not? Oh, how can I zoom in here? Yeah, I'll do that. Let me zoom in. Where is it? It's the view. Zoom in, man. Zoom in is control plus equals. Really? All right. How's that? Nicer?
Oh yeah,
Okay, good.
excellent.
All right. All right. So we read in, so we're going to read in this data.
Mm-hmm.
Okay. And it's found online here, like I said. So I've created something called DAT that looks like this. Okay. So there's not showing us 150 rows. There's a lot of data here.
Mm-hmm.
And it shows for graduate students that are trying to get into university. I don't know if this is worldwide, but in the States, there's a GRE that people take.
Okay.
Or the GRE is that may be to get into university or to get into how do you call it, post grad, or maybe into a master's or a PhD program. Anyway,
Sure.
these are the scores that they get on this particular test. So that's going to be our continuous variable,
Mm-hmm.
as well as their grade point average. And I imagine this is on a 4-point scale. Okay. And also they've thrown in rank, meaning that they've ranked the particular university that, or sorry, either particular university or the particular high school, wherever, whatever institution they've
Right.
just finished, what rank it falls into as far as 4 ranks. So rank 1 would be the top tier, and then rank 4 would be somewhat less prestigious, I imagine. Something like that. Okay, so
Okay.
they have those 4 ranks in there as well. All right. So we've read in the data. Beautiful. So we're going to see what the probabilities of acceptance given the GRE, possibly, or maybe we can even do GPA. I don't know if we'll have enough time to do 2 continuous variables, but I did set up something here for throwing rank in there as a factor to kind
Mm-hmm.
of see if that makes a difference a little bit. So
Nice.
hopefully all of this is going to work correctly, and we're correctly interpreting it. Okay.
Okay.
So, all right. So we've read it in. It happens to be the names of our data frame. So there's the names. We're going to use that. You're going to find that in this code here. So here we're creating a model, right? GLM is generalized linear model, but
Mm-hmm.
specifically a binomial. Okay, the
Right.
family binomial. This is going to give us the logistic regression that we want. Okay,
Cool.
so I've named what data set we're talking about. DAT is what we called our data set,
Mm-hmm.
and we want to see how whether they were admitted or not, how it might vary as GRE, what the probability is of somebody getting admitted, how it might change with GRE. Okay, so
Right.
or that they did on this particular exam, the standardized exam. So let's run this thing, our model. Okay,
Mm-hmm.
and we look at the summary. Here's where we see if if it has a significant effect. Okay,
Okay.
so we've run specifically a logistic model here. Okay, and here are our outputs. Here's the beta 0 that we were talking about, negative 2.9, blah blah blah.
Mm-hmm.
Okay, then according to what the estimate is and the standard error, that's going to give us a z value, and that in turn is going to give us a p value. And if we get p values that are less than 5%, which is usually our level of significance,
Indeed.
know that there's significant that particular term is significant. Okay,
Excellent.
so the intercepts I imagine are assumed to be 0. Sorry, the coefficient and intercepts are assumed to be 0, and here they're letting us know that what the estimate is, and because the standard error is relatively small compared to these values, we see specifically we see specifically which ones. I'll talk to you soon. Bye. No problem. No problem. All right. Sorry,
No worries.
my fans. Just kidding. Oh, no, that's a very nice gentleman. Anyway, so both the intercept can be used as well as the coefficient on our GRE. So this would be our beta 1. This would be our beta sub 0.
Excellent.
That would be how we would get the probability, okay, by taking e raised to this plus whatever our GRE score is times this over the 1 plus that bit, right? In fact, here, I'll write it down. I forgot that we have the annotate feature here. So let's see if I can, that's going to help us here.
Oh, fantastic.
Is that working? All right, cool. I'm going to write over here like a whiteboard. So we said probability, probability of getting an X equal to 1, people being admitted are going to be equal to E, our natural exponent, raised to the negative 2.9, was it? We'll say 2.90.
Okay.
Plus whatever your GRE score is. So I'll put our X value as our GRE score times 0.00358.
Yeah.
358. So there it is. That over 1 plus this bit E raised to the negative 2.90 plus X times, not the conventional way to write it, but that's fine. We make our own rules around here. 358, sorry. 58, 8, that's an 8. Okay. So we pop in our GRE score here and here, and that's going to give us a probability. Okay.
Excellent.
So it happens to be a positive value, isn't it?
Yes.
Right? So we should expect something that looks like this. Right? As our GRE gets bigger, our probability goes up of being admitted into that particular university or into the being admitted into university.
Sure.
Right?
And that makes sense. That seems correct, like in real life.
Yeah, it would. It would. I mean, the higher your score on a standardized test, the more probable that you're going to get admitted into the university, which is good.
Yes.
All right, cool. So actually, here, let me get rid of all of this. Let me put that in the bin. All right, and actually get some nice. See if we can, and we can make this code available too for people that they want to go through this. So if they want to, be able to run this exactly the way we ran it, make the code available. Okay, let's see here. All right, so I've run the model. Where am I here? The summary. Okay, so I'm in this particular case, what I'm doing is I'm using the predict function and telling it, hey, I've got a model that I want you to tell me what the response is, okay, by predicting those values. So it's going to take the actual values of GRE, plug them in to our equation, it's going to plug it into the formula that it just gave us in the summary. Specifically, where is it? These values over here, right? This guy and this guy. And it's going to let us know what those probabilities are going to be. I believe that's what's going to happen. So I'm going to end up here creating a vector that's called prob, and that looks like this. So according to what the GREs are in my data frame, right? The first one had a GRE. They gave us a probability of getting accepted being this.
Right.
And being this and being and so on. Okay. So these are in no specific order. They're just, those are the probabilities we get according to whatever GRE they had. Okay. Right. So that's a vector of predictions. What I'm going to do now is create a new data frame by column cbind, means combined columns of my original data frame and this new vector that I just put in. Okay, so it should give me predicted values put on next to the actual data set that I have. Right. And now I'm using ggplot here, which is a very, very nice package that allows us to make some really, really beautiful graphs. And I tell my students here, even if they don't do a lot of statistics, it's worth learning how to use RStudio just to be able to get a lot of use out of ggplot. It makes really beautiful graphs. Okay.
Excellent.
So this is a specific type of, so we use the ggplot command, which ends here, and we let it know what data we're going to be using. It's the new data set that I combined here. What we want along the X, what we want along the Y, right? Which was this last vector that I tacked onto that data frame. And basically it's going to lay out the X and the Y. If I just ran this, I don't know how familiar people are with RStudio, but if I just ran ggplot without the rest of this business here, right? That's the ggplot command. It gives me a grid, but doesn't really plot anything.
Oh, that's annoying.
Yeah, right? Okay, so it gives me that, but I need to let it know what I want it to do. So I'm going to use the GEOM, right? Any prefix, the prefix here for any one of the symbols that are going to be used, or any types of the types of graphs that are going to be used, I'm going to have a prefix of GEOM underscore, and then in this case it's smooth, which is going to put a smooth curve, and we're letting it know that we're specifically talking about a generalized linear model of the binomial family. Okay, so it knows specifically what it's going to be graphing now. Okay, if I just put here LM, it would just put the linear model that fit that data. Okay, but here we're letting it know specifically that we want if to smooth it with a particular family, a particular type of smoothing, generalized linear modeling in the binomial family, the logistic, right? Okay. All right, so let's do this then. Let's run this whole thing here. We've created something called PLT here, which happens to be this ggplot bit with all of these extra bits of information, all these extra options thrown in here. And now let's actually see what PLT looks like. So let me run this. Fingers crossed. Okay. So we get, what do we get here? We actually get not as pronounced a sigmoidal curve as we were showing, the ones that we were drawing up on drawing, but we got something that we expected to see, right? We're expecting to see as your GRE gets higher and higher, your probability is going a little bit higher as being accepted, basically. Yeah. Pretty cool, huh? Very, very cool. All right. If we have a little bit more time, we can also see if there's some kind of I don't want to say it's nepotism. It's not nepotism necessarily, but when you come from a highbrow school, sometimes, it might make a difference. You want to see if it does?
Sure.
All right. Okay. Let's see. Okay, I'm going to read in the data again because I think it's always good practice to start from the beginning so that we haven't adulterated our data set, which we're calling DAT. So I read it in again. And it's always a good idea to run your code from the beginning. I actually Googled this warning and they said, I've seen a bunch of forums say, never mind, don't worry about it. So that's why I'm kind of ignoring it right now. That's okay.
That's good.
All right, so we read in our data. Okay, so here we're going to actually have to make rank a factor, okay?
Right.
Because it's more ordinal than it is, how do you call it, like a continuous variable. Right. Makes more sense to throw it in as a factor. So that's what's happening here. I'm overriding rank with the same numbers, but making it a factor. I'm creating a model now that not only takes GRE, but also takes rank into consideration. So let's see what that's going to look like. And now let's look at a summary. Okay, so let's see. Oops. Okay, so we still have a usable intercept because we have a p-value less than 5%. We're still going to use GRE as our as our continuous variable here, because it's also significant. And we see that here we have rank 2, rank 3, rank 4, okay? Basically, what's happening here is, if I use this and this, I'm basically using the GRE score to figure out what my probability is of getting accepted for the base case of the factors of the rank. So for rank 1. And these bits here, these values here, here, and here are the adjustments we need to make going from rank 1 to 2, going from rank 1 to 3, going from rank 1 to 4. And we can see that all of those here are significant. So basically, these are the values, right? So if I had a GRE value for a rank 4, okay, I would use this as my intercept, my beta naught. I would take the GRE and multiply it by this number, still a positive effect, it looks like. But then I would also tack on this value, okay, which looks like it's like every rank going from 1 takes a little bit off of that, doesn't it?
It does, yes.
So that looks already, it looks like the rankings, you know, well, it's,
So
you get, go ahead.
Sorry. So you don't need to
multiply that by 4, that minus
No.
1.6.
That's a great question. Since it's being treated as a factor, it's just letting you know that for this, yes, it's just saying, here's the adjustment, and whether it's significant or not, here's the adjustment that needs to be made from the base case to this particular case.
Got it.
Yeah. And I mean, you could almost make the case of if you go up by the same amounts, like you went to negative from, you had to adjust to negative with a negative 0.72 going from 1 to 2. If you had negative 1.4 to go from that bit, and then whatever the third amount was, 3 times that first increment to get to this, then you might say, I could have left them in as a numeric value. But here it's categorical because there may be different adjustments that need to be made.
Got it.
Right? Cool,
Thank
man.
you.
You're welcome. You're welcome. All right. So let's see. Now, I think I've got a little bit more. So again, I'm gonna predict using GRE and specifically the rank in this case, because that's what this model contains, right? Yeah. So it'll give me the results, the probability values for specific values in our data set. My new data frame, I'm actually creating a different one by saying, instead of using the combined column, I'm taking out specifically, where is it? The GRE values. I'm creating another data frame, which is called new data, new DAT. First column is going to be swiped from my DAT data frame, my original data frame. Probability is going to be these values that I just used the predict function on. And then I'm also going to throw in the rank. Now, I don't know why I put as factor in here again, but since I'm creating a new data frame from a previous one, I'm not sure necessarily if it's going to read it in as a factor or if it may read it in as numeric. I'm just making sure it's reading it in as a factor. Okay. All right. So we're creating a new data frame. And what am I doing here? Why am I doing this bit? Rank is as factor, new rank as factor. I don't know why that's there. Let me run this bit right here. If I get an error, then I'll know why it's there.
Right.
I got a bunch of warnings, but no error. Okay. All right, and it's the same one that we were told not to worry about. So here we're actually seeing, okay, each one of those values being put in, okay, each one of the adjustments that are made, right, and kind of giving us what the differences are between the ranks. So you can notice that the ranks for the GRE score, I mean, starting off for the GRE score here, right? Okay. They have a lot higher probability of this guy, or this guy, or this guy, right?
I'm sensing nepotism.
Look at them laid out exactly the way that they're in order. You know, not too much from 3 to 4.
No.
But, you know, I mean, so you can see something's going on there as well. All right. Now, I don't know what the rest of this is. There's there's one of the references. So that's in the code that I put in. So, so it's there. Okay. All right. So what did you think of that? Okay.
That was really cool. I like
How succinct it was. I don't usually use R, so seeing everything all laid out and then following each step, it made it really clear.
Oh, that's cool. That's good. Maybe we can use that a little bit more because here, let me actually stop this share here. Could you make it, you know, we could use it a little bit more, and then it's good practice too. You know what I mean? Because, you know, sometimes you'll run into like a lot of this stuff. I use that particular website. I think it was like just a community that comes together and one person answers another's question. But it's cool to be able to work out those problems to get exactly the graph that's going to show what you want to show. And it picked some nice colors too, now that I looked at it.
Excellent.
All right. Not as nice as these colors or the colors behind you.
There we go.
But still. Yeah, and you can go in and put any color that you want, specifically, whatever the code is, you know, that so. All right, okay. How was that, Laura? Okay.
That was pretty cool. I enjoyed that.
Thank you very much.
Yeah, that lady's still hanging out over there, man. I'd keep an eye on her, the one with the pink.
Yes, lady?
You
Oh, my
look,
hand's disappeared.
you
There
look,
we go.
you look back too. I try to bait you to look back. It's like, oh, how beautiful! Ah, I go dive in. I go dive into the water over here.
Amazing.
Always fun. It's always fun. So hopefully it's informative too.
Indeed.
Watching, we had fun. So why do we care? Right?
Absolutely.
All right. All right. I'll talk to you. I'll talk to you soon. Okay.
Great. Until next time.
Until next time, everybody.
Bye.
Bye.